Hello.
Hi, how are y'all?
Welcome back.
This is not gonna be my day.
Oh no.
Okay, question. Anyway, so far. Again, let's see where I can get to here. There we go. I'm back. Now I got to share with you again. Have mercy. Okay, let me see. Let's try it. Come on, come up. Okay, let's just pretend the last 4 minutes didn't happen. Questions, anybody? Questions, anybody?
Okay.
All right. I want to review one other thing, and then we're officially a full day behind, and that's okay. What that says to me, to you, is when you look at your homework tonight on the assignment sheet, forget it, okay? All you have to do for me now is to get the next quiz to me, hopefully by the evening. So I said 5, get it to me by 8. I'll be grading all night long anyway, so it doesn't really matter. But it was on antiderivatives. So let's do a couple on antiderivatives and make sure that everybody's okay on that. And that's what I want to finish up doing. So the homework for tonight officially moves till tomorrow. And then I'll remake what I have to, okay? What we've learned since we did all this exponential stuff is where we came to chapter 5. All right, chapter 5 was about antiderivatives or integrals. If you have not done this, the homework up until tonight, use tonight as a chance to kind of catch yourself up. So what we did with an antiderivative was we're given a derivative and asked to find out where it came from. Whose derivative was it? Our main rule looked like this. The integral or the antiderivative of x to a power adds 1 to the power and puts it over that and adds a c. And we saw during the last lecture how we could find out what that c was. Remember, we were kind of determining a member of the family and that kind of stuff. I'll put that truncated video online for whatever it's worth. I don't know about the second half. I may put it on as part A and part B.
Could you do a problem that is like, it's long, it has a lot of numbers, but at the very, like in the problem, it has a 1 in it?
Okay.
Or just any constant, really. It doesn't have to be 1. Just.
Okay. All right, we'll do that. I'll make it. You want a long one, Haley? I'll give you a long one. There you go. How about this? You can do this one. You can do anything I ask you, okay? All right. Everybody, I want to look at this one. The first thing I want to do, just like I did with derivatives, is rewrite things in terms of powers. Because, guys, that is basically the only rule I've got. I got this power rule. So I'm going to rewrite it. These two are okay, because that's 2x to the first, basically. This needs to be written as x to the 1/2. This needs to be written as 2x to the -3. That is just 7, and there you have it. Okay, is everybody okay on the rewrite? You cannot use the power rule until you rewrite these radicals and until you get any power that's in the bottom up to the top. Okay, so let's go ahead, let's go do it. Let's use this rule right here to find the antiderivative. Whose derivative is that ugly thing? The rule says this. The 3 is just a constant, so it just stays there. What do I do with the power here, guys? What do I do? What's the antiderivative of x squared according to this rule?
So you put x and then you put 2 plus 1 over
Right.
2 plus 1?
Plus 1. Yeah, I just add 1 to it. I say x to the 2 plus 1, which is 3, and I put it over whatever I get there. I put it over the same thing. See how these are the same, n plus 1 and n plus 1? So you add 1 to the power and put it over that. Okay. Now I'll simplify it later. The next one's -2 times something. Everybody look at it. What's the antiderivative of x to the first going to be?
1 plus 1.
1 plus 1 is 2, so it'll be x squared, and I'll put it over a 2.
2.
Oh, brother. Hang on. Let me get rid of this. Can y'all see that?
Yeah.
Okay. Oh, shoot.
So antiderivatives, you're just adding the exponents together and
Yes,
you leave
I'm
everything else
adding a
alone and then
1.
put it over the main number.
Yeah, that same number, not the main number, but this two could have been something else. The power rule, that 2 came from there. This other 2 came from putting it over, adding 1 to that power right there.
Oh, okay. So it's not like the original
No,
2.
no. Actually, you'll see that in the next step. Okay.
Okay.
The next one's going to be this one. X. What do you get when you add 1 to a half?
1.
You get
1.5.
1.5, which is 3 halves. So 3 halves over 3 halves. So Katie, you see what I did? It didn't matter what the coefficient was. You put the same thing you got here down there.
I see. Perfect.
Okay.
Yeah.
Now, if you wanted to, guys, you could invert and multiply this, but I'll clean it up in a minute. Careful with the negatives. There's a 2 here. What do you get when you add 1 to -3?
-2.
-2, so that'll be x to the -2, and I'll put it over that same -2. Everybody with me?
Yeah.
Yeah? Okay, here's what Haley originally asked about. Now, whose derivative is 7, guys? What would I have to differentiate to get 7?
-7x.
Yeah, 7x. Well, it has a negative with it, so 7x. Look, guys, rule. Here's a rule. You want to see a rule? Here's a rule. It's just a constant. The integral is k, that constant times x, period.
So you wouldn't do like -7x and then you wouldn't put it to the 1 + 1?
No, because look, here's what you're really doing, Haley. You want to see the actual power rule on that thing? Look at what I might do here. Will you agree that -7 times x to the 0 is the same as -7? Because what is x to the 0?
0.
No, x to the
Well,
0
x.
is 1, okay? So I am, in a sense, using a power rule, but we probably wouldn't do that. I'm just stating this as a rule. Now, if you add 1 to that, you will get 1 and put it over 1. So, I mean, it's a power, but you don't need to remember that. You just remember, if I've got a constant, where did it come from? Well, it came from that constant times x to the first, period. Okay? So I would then add a plus c. All right, let's see if I can ingrain that in you here. I would then, by the way, on this one, guys, I'd start to simplify a little bit. This one would be, you'd invert and multiply there and get 2/3. That would leave me with a -1 because of that minus down there, and so on and so forth. Suppose I said, what's the integral of 5 dx? Whose derivative is 5? Anybody?
X.
5
5x.
times x. 5 times x. So that's 5x, and then we'll have a plus c. How about the integral of 4 dx? Whose derivative is 4?
4x. 4 times x.
4 times x. All right. How about the integral of -10? Whose derivative is -10?
Minus 10 times
-10
x.
Yeah,
plus-
plus c. Okay, I gotta add the plus c. What's the antiderivative of 3 dt? Now, guys, that little end piece right there just tells you what the variable is. It's not
So-
x anymore, it's t. So what's the answer to this one?
3 times x.
3 times, but it's not x anymore, it's what?
Or d.
It's t. And I still
T.
have to put the plus c. Okay, so what's this one? What's the integral of 45 dp?
45p plus c.
Yes, 45p plus c. These two signs go together, this dx and this integral. It just tells you what variable you're working with. Because if we had a business problem, the variable might be t. It might not be x. It might be time in years or something like that. Quickly, and then I'll let you go, guys. If you want to find, if you say here is an antiderivative, you're going to get 2x squared over 2 plus 5x plus c. So there's the function that it originally came from. x squared plus 5x. You can always check this by taking the derivative and making sure that's what you get. It's a reverse process, but you can, now you get the answer, you can go back and see, yeah, that's right, because the derivative of x squared plus 5x plus c is 2x plus 5. Now, if you want to know what c is, you'd have to know that at what point it went through. So suppose my function went through the point 1, 2. In other words, f of 1 was equal to 2. I would plug in the 2 for y or x, or y for f of x there. I'd plug in the 1 for x. I get 2 is 6 plus c, so c is minus 4. So remember this was a family of curves, and now if I give you a point on that curve, you can find out what that needs to be. I'll go back and watch the last lecture. I have not done anything new today. Nothing all. That's fine. I don't have a problem with that. I'm not in a race here. I'm not in a race. So, but I want you, there's a certain amount of things I want you to see here. So go back, try to catch up, do some things you haven't done. The antiderivative quiz is this stuff. While it's fresh in your mind, while I've talked about it, do it, write it, rewrite it, anti-differentiate it. And that's what this symbol is. It's called an integral symbol, and it's anti-differentiated. Okay. Are we okay? Everybody okay? I think I am. I'm not really sure, but I think I am. Questions, anybody?
I have one more question.
Okay, Haley.
What happens if the x is in the bottom?
What you do is, you know that from algebra. 1 over x to the nth power is x to the minus n. You got to bring it up.
So if it's like x and then you bring it up, it's x to the minus 1. Would you then add 1?
Okay, yeah, but here's the problem. The power rule for antiderivatives works for every power except n can't be minus 1. Because when you add, what do you get when you add 1 to minus 1?
0.
And you can't divide by 0. Remember how we divided by the same thing?
Yeah.
Did I have one like that on the quiz? I didn't, did I?
You did.
I did. Eliminate it. I probably didn't. In my rush to get to the rule, I probably didn't say that. I tell you what, if you had something over x in the quiz when you had to divide by it, don't worry about it. I don't have the quiz in front of me. Don't worry about it. Eliminate that problem.
Okay, because I got when I did that problem x 0 over 0, which you couldn't do. So then I just did not put that in the answer. I just
that was a smart thing. You cannot do it. The power rule for antiderivatives works anytime except when n cannot be minus 1, because if it were minus 1, you'd get a 0 in the denominator. So n can't be minus 1. You can do 1 over x squared, but you cannot do 1 over x. That would be x to the minus 2. This would be x to the minus 1. I'm sorry about that. Was that with the division problem?
Yeah, it was like the x squared plus 2x over x.
Okay. X squared plus 2x
over x.
X squared. Let me make sure I'm eliminating something right. X squared plus, say it to me again, x squared.
X squared plus 2x over x.
All right, what do you get when you divide that? What's x squared over x?
X plus 2x.
What? Yeah, it's x plus 2x over x. Write it with the common denominator. I don't think I have a problem here.
Well, I didn't divide it. I just brought the x up. So
No. You don't have a quotient rule for antiderivatives. You have to either multiply it out or divide it out. Here's my hint on this one. Divide it out. And then you can do it. What is it divided out?
X plus 2.
X plus 2. And now you can do that, can't you? Everybody should be able to do that one. That one's pretty easy. Look, Haley, here's what you did.
Yeah.
You brought it up as an x to the minus 1. I get it. If you look at the problem before that, I said you must multiply it out. You must multiply this out. You do not have a way to undo a product. All you know is how to do pluses and minuses here. That's it. That's all you know how to do. So you'd have to multiply it, which still would be 2 plus minus 1 is x. X to the first times x to the minus 1 is x to the 0. It's that. So if you see a product or a division, you must multiply it out or you must divide it out, because you only know how to do integrals that have terms that are added and subtracted, period.
What if I did, instead for the beginning, I did x parentheses x plus 2 parentheses divided by x dx, and then removed both of the x on the outside of the parentheses and the x on the bottom?
Who's talking to me? Who's that?
And
This is hard now because I'm confused.
No, listen, I'm telling you that if it's a quotient, you need to divide it out. If it's a product, you need to multiply it out.
But there's something in the denominator, whether it be a number or an x or an x squared, or what do? Do I have to use that rule?
If it's a division, you divide it out. You only have a rule for the sum of things. You can add and subtract things, and add and subtract things. You cannot multiply them. So if they're not already multiplied out, you must multiply them out. So that'll be x squared plus 5x plus 6, which you know you can do, because that's just stuff that is added.
Okay, well, I think I did every single one wrong on the quiz then. Do you think
I don't think you did. I don't think you did, because if you have for instance, if you have x cubed over 3, guys, that's just the same thing as 1/3 x cubed. I mean, you can still use the power rule on that. It's just 1/3 x to the 4th over 4. Okay, so if it's a constant, you don't need to worry about bringing it up or down. It's just a fraction times something. It's just a fraction times something.
Do you think you could look at my quiz and tell me, like, if I did everything wrong, and then let me know? And then
after I get out of my 1 o'clock class, my 2 o'clock meeting, and my 3 o'clock meeting, I'll look at it, okay?
Okay.
I promise I'll look at it. But guys, look at it and at least make an attempt at it. But on those two, where it's a product or a division, multiply it out and then do each one individually, divide it and do each one individually. That's the only thing different you have to do on those. The other ones should be pretty standard, just rewrite things. So yeah, okay, I'll just do what you can on it, and let me see the kind of mistakes people are making if you don't get it figured out, and then we'll come back and look at it together.
Okay, because I turned it in last night.
I know. I saw it. I saw it, and but I didn't grade it because I was waiting for the other ones to come in. So, but try to. I tell you what. Yeah, I'll mark it, and then you try to redo it. Okay.
All right.
Based on what I've said here. And I'll tell you the ones you've gotten right at least, and then you can look at the other ones.
Okay.
All right. Thank you guys for hanging around. Is everybody okay? Okay. We'll
Thank you.
You're welcome. We'll come back and we'll talk tomorrow, okay?
All right.
All right,
Thanks.
bye-bye.
Thank you, bye.
Bye.